Hey everyone, welcome back to FoxLearn today. I'll show you how to build a full CRUD application with ASP.NET Core MVC, .NET 9, and Entity Framework Core, step by step. First, open Visual Studio 2022 and create a new project. Then choose ASP.NET Core Web App, Model View Controller from the project templates. Click Next, give your project a name, then choose .NET 9 as the target framework, and click Create. Next, open the Package Manager console or use the NuGet GUI and install the following packages. These packages will allow our application to interact with a database using object-oriented code rather than raw SQL. We'll be using EF Core for tasks like querying data, saving changes, and managing our database schema. Now let's create a new folder called Entities. Inside this folder, we'll define a class named Student, which will represent the data model for our application. This student class outlines the structure of the data we'll be working with, including properties like ID, name, email, phone, and address. In other words, this class acts as a blueprint for what a student looks like in our system. We'll use this model to interact with the database, to store, retrieve, and update student records, using Entity Framework Core. Next, let's create a new class called Application DB Context and have it inherit from DB Context, which comes from Entity Framework Core. This class acts as the database context for our application. In simple terms, it's the bridge between our C# code and the actual database. By inheriting from DB Context, we get access to powerful features that handle key database operations like querying, inserting, updating, and deleting data. Inside this class, we'll define a DBSetStudents property. This tells Entity Framework that we want to create a table in the database for the student entity, and that each row in that table will represent a student object in our code. You can think of a derp set as a collection, one that EF Core uses to track and interact with records in a specific database table. The application DB context is essentially our data access layer, and it's where we define which models, like student, should be mapped to the database. Later, we'll configure this context to connect to a SQL Server Database, so EF Core knows exactly where to store and retrieve our data. Now, open the App Settings JSON file. This is where we store configuration settings for our application. Inside the connection string section, add your SQL Server connection string. This tells Entity Framework Core how to connect to your database, including the server name, database name, and authentication details. Make sure your connection string is accurate, because EF Core will use it whenever we run migrations or interact with the database. Next, open the program.cs file. Here, we need to configure our application to use Entity Framework Core and connect it to our database. This line of code retrieves the connection string using the key name default connection and tells EF Core where to find our SQL Server Database. Now, by adding this configuration, we're enabling dependency injection for our DB context. This means our app can access the database context anywhere it's needed. Clean, efficient, and scalable. Next, we'll register application DB context in the services container using the connection string we set earlier in appsettings.json. Now open the Package Manager console in Visual Studio. This is a powerful tool that lets us run commands to manage our application and database. In the console, we'll run a command to create the SQL database based on the models and configurations we've set up so far. This command will apply the migrations and generate the actual database schema in SQL Server, so you can start storing and managing data right away. Next, let's create a new class called Students Controller that inherits from the base controller class. By doing this, we gain access to key MVC features like action methods that respond to user requests and views that render the UI. This controller will handle all the logic related to managing student data. After setting up the controller, we'll create an index.cs HTML view. This will serve as the main page to display our students. We will add a link that calls the index action of the student controller, so users can easily navigate from the home page with a single click. In our controller, we start by injecting application DB context through dependency injection. This gives us direct access to the database so we can perform CRUD operations easily and efficiently. The index action method fetches all student records from the database asynchronously and passes them to the view, ensuring smooth performance without blocking the UI. Open index.cshtml and add HTML to display a table of student records. First, declare the student model at the top. Then use a loop to render each student as a row in the table. To define the table headers, place them inside the T-head tag. Add rows inside the T-body tag by looping through the model items and using HTML display4 to show each value. Next, we'll add a table inside the class and apply some styling to make it look better. To use data tables in your ASP.NET MVC project, just copy the CSS and JavaScript links from datatables.net and paste them into your _layout.cshtml file. Now open the index.cshtml file and let's enable data tables for our HTML table by adding a script section at the bottom of the page. Inside the @section scripts block, we write a small jQuery function that runs when the page is loaded. @section scripts allows us to insert page-specific JavaScript into the layout. Next, we have two add methods. The first one, marked with HTTP GET, simply returns the form view where users can enter details to add a new student. The second, marked HTTP POST, handles the form submission. Here, we validate the input. If everything looks good, we create a new student object and save it to the database. We will create a student view model that acts as a bridge between the view and the model. This view model will help us bind the data so changes in the model reflect automatically in the view and vice versa. Let's walk through the add method in our controller, which handles adding a new student to the database. The bind attribute is used to protect against overposting attacks. We're explicitly stating which properties should be bound from the user input: ID, name, email, phone, and address. Here, we're checking if the submitted data is valid, meaning it passes all validation rules defined in our student view model. If it's not valid, the form will be shown again with validation messages. If the model is valid, we create a new student object. We assign its properties using the values from the student view model that the user submitted. Next, we add the new student object to the database context. Then we call save changes async to save the new student into the database. Notice we're using await. This makes the operation asynchronous, which helps with performance, especially on larger applications. After successfully adding the student, we redirect the user back to the index page, which typically shows the list of all students. If the model is not valid, we return the same view and pass the student model back. This allows the form to be re-rendered with validation errors so the user can fix any mistakes. Now we will create the add.cshtml view. This Razor page will display the form where users can enter student information to be added to the database. We start by specifying the model at the top. This tells the view to use the student view model so we can bind form fields to it. Next, we add a heading and a form. This form will send data to the add action in our controller when submitted. At the top of the form, we include ASP validation summary, which displays any model-level errors, such as missing required fields. Each input field is bound to a property in the view model using the ASP for tag helper. Below each input field, we use ASP validation for to display validation messages when the input is invalid. At the bottom, we have the Submit button. When the user clicks this, the form is submitted to the controller. We finished the add action, so now we will add a few example students to try it out. Now, let's look at the code for editing a student record. This feature is handled by two methods, one for displaying the form and one for submitting the changes. The HTTP GET version loads the existing student's data by their ID and passes it to the view, so the form is pre-filled with current information. If the student is found, we create a new student view model and copy the data from the database into it. Finally, we return the view and pass in the model so the form will be filled with the student's current data. The HTTP post method handles updates. It validates the submitted data, updates the student record, and saves the changes to the database. First, we check if the ID in the URL matches the ID in the form. If not, we return not found. Then we check if the submitted data is valid using the isValid property. If the model is valid, we create a new student object and update its values with the form data. We update the student in the database and save the changes. After saving, we redirect the user back to the index page. If the data is not valid, we return the same view with the student model so the form shows validation errors. Next, we'll create edit.cshtml, just like we did with add.cshtml. It will use the same form layout, but it's for updating student information. I forgot to assign the ID to the student object, which caused a new record to be added instead of updating the existing one. Finally, the delete method lets us remove a student record. We first check if the student exists, then remove it from the database context and save the changes. Now, let's go back to index.cshtml and add the functionality to delete a student record. We'll use a hidden form and JavaScript to handle the deletion. First, here's the form that handles the deletion. This form is used to send a delete request to the server. The ID is stored in a hidden input, and the anti-filler is security. Now, we'll add the JavaScript to trigger the deletion when the user clicks a delete button. When you click the delete link, a confirmation pop-up appears using SweetAlert. If the user confirms, the ID of the student is set in the hidden input field, and the form is submitted to delete the record. So that's a complete overview of the Students Controller. It supports viewing, adding, editing, and deleting student records, all built with best practices like asynchronous operations and model validation to keep the app responsive and reliable. Now, go ahead and run the application to give it a try. Add new students effortlessly, edit existing records with ease, delete entries safely, complete with confirmation prompts, and enjoy smooth searching and pagination powered by data tables. At the bottom, we include validation scripts, enabling client-side validation with jQuery so users get instant feedback before submitting the form. That's it. You've just built a complete ASP.NET Core MVC CRUD application using .NET 9 and Entity Framework Core. Thanks so much for watching. If you enjoyed this tutorial, be sure to hit the like button and subscribe for more step-by-step guides on web development and programming. Got questions or ideas for future videos? Drop a comment below. I love hearing from you. Until next time, happy coding and take care.